Hi, everyone, and welcome to another episode of Living on Blockchain. Today, we are speaking to Stan. Stan is the co-founder and CTO of SKALE Labs, a gas-free invisible blockchain network designed for secure Ethereum scaling. He has been around for a while, and he's actually been around on both sides of the stream, be it academia as well as the industry. He holds a PhD in physics, and he has been fairly lauded and given a lot of prestige in the academic world, and he has been working as an entrepreneur for several years as well. He's an active member and contributor to the Ethereum Research Foundation. This was a very, very interesting conversation just owing to his experience and how experience can really change the way you build as an entrepreneur. So very insightful conversation. I can't wait for you guys to hear this. Let's deep dive right in.
Hi, Stan. Thank you so much for making the time to speak to me today. How are you doing?
Good. Therefore, let me introduce myself a little bit to the listeners. So my name is Stan Kladko. I am the Chief Technology Officer and also co-founder of SKALE Labs. SKALE Labs is a network of blockchains. I think we're going to talk a little bit more about it today. And I'm actually calling from Portugal, from Lisbon, Portugal.
Awesome. Thank you so much for setting the tone right for this particular recording. Now, can you tell us a little about your journey so far? How did you get into Web3, Stan?
Yeah, that's kind of an interesting, as everything is in life, it's a little bit interesting and chaotic. So I'm actually a researcher. So in my former life, I spent lots and lots of time in physics. I did my PhD in Germany at Max Planck Institute. Then I moved to America. I was at Los Alamos National Lab in New Mexico for 2 years. And then I was at Stanford University doing research in physics. My boss at Stanford was actually a Nobel Prize winner in physics. He did all of the cool things about quantum mechanics, quantum magnets, all of this stuff. So I actually never thought I was going into crypto. But then what happened when I was at Stanford, I took a really interesting course from a professor. His name is Dan Bonnet. He is world's famous cryptographer. So I took a course from this professor, and then this professor, he was actually starting a startup. The startup name was Ingrain Network. It was a database encryption company. Long before the crypto, it was just cryptography. The startup was encrypting databases. So I basically joined the startup, and since that time, I was in cryptography actually. I founded a startup which was doing cryptography for Wi-Fi. This startup was sold to a telecom company in the UK in London. And then I started a cryptography lab, which was doing cryptography analysis for the US government, for the US military actually. And so I was actually doing this thing. And then after several startups, I was doing an AI startup. And then the Ethereum network actually started. So that's how I actually moved to cryptocurrency.
Oh, wonderful. That's quite a journey. And, you have such varied academic experience as well as experience with startup. Can you tell me a little from how did you go from like an AI startup and to crypto and then, to scale?
Yeah, that's actually like interesting stories. So we were running this AI startup and then Ethereum network started. And basically our venture capitalists told us to look into crypto. I knew about Bitcoin, but I was kind of not so much excited about Bitcoin. But then when I heard about Ethereum, it was totally clear to me that was great because Ethereum added the function of actually running programs on blockchain. So with Ethereum, you can actually run all kinds of things. It was so exciting that actually I got a ticket to Cancun and I flew to DevCon, which was one of the early DevCons, meet Vitalik Buterin, actually met all kinds of people, and then started thinking how to do crypto. So then I actually met my co-founder, Jack. He was also doing lots of crypto and interested in the new thing. And we started thinking about what can we do. So the idea was that at that time, especially, Ethereum was really slow, and we started to think how we can make it faster. So we came up with this really simple idea that you can run sort of a network of blockchains which are compatible to Ethereum and are helping Ethereum. And these blockchains you can have any number of them. So you can have many blockchains, and all of them can help Ethereum and help it scale and help it to have many transactions. So that was the idea pretty much. And then we actually were were actually really lucky. We got money from venture capitalists, some of the really top venture capitalists in the world, and we started building this. It was long time building. Then we launched the network, and now we're actually running lots of games, running lots of AI applications. So it's actually pretty successful as a project.
Wonderful. So Scale is L2, and that is it's kind of powering the L2 infrastructure, and it is also I believe it is also like a ZK EVM, right? And it is compatible. So can you tell us a little about what a developer can expect out of Scale?
Yeah. So basically, the idea is that you have Ethereum, right? And Ethereum runs transactions, but you pay per transaction. But then you have a game or you have an AI application, and this AI application needs to run many transactions, way more than Ethereum.
Yeah.
So what you do, you actually deploy this AI application or the game. You deploy it to one of the blockchains on Ethereum on Scale Network, and the application runs. But then, if you want to have a token or you want to communicate with Ethereum, you have a really fast bridge that connects Scale Network to Ethereum, and so you can go back and forth. If you want to actually do something on Ethereum, you can move your token to Ethereum, do things, and then you can move back. So that's the architecture, and that's where we are now. As far as the future is concerned, we are thinking about ZK, but in addition to ZK, we are thinking about some other really interesting mathematics. So this year is a big thing for us because we are going to deploy all of this new math to our blockchain. And in particular, one really interesting mathematical subject is being able to have encrypted transactions. It comes from the point that you actually need to protect your information, basically. So that's kind of the big thing for us, this new encrypted transaction.
It's more privacy focused then.
Yeah, so basically, I mean, if you look at Ethereum, for instance, or other networks, there are lots of good people, but there are also lots of bad people, right? Like you submit a transaction, and someone actually sees the transaction, the information, and then they can front run the transaction, then can exploit. And I think even during the crypto winter last year, there was about $1 billion actually kind of stolen. You can think stolen or compromised on these blockchains because of these bad people. So with this new technology that we call BITE, blockchain integrated threshold encryption, what we do is when you submit your transaction, it's encrypted. No one can see it. So you can actually trade on DeFi, you can use exchange, you can trade tokens. And then when the transaction is on blockchain, is actually decrypted and executed. So it's only encrypted during this short period of time when you submit. So it's not really privacy. It's actually protection against something which is called MEV or front running, where people use AI or bots to actually exploit you.
Yeah, that I've heard of. Yeah. So that kind of that would be perhaps not something that you'll have to worry about if you are using Scale.
Yeah, totally. And that's actually a big thing that we are working on because one of the reasons people don't use decentralized applications is because of this MEV/exploits. So to give you a really simple example, right? Like let's say you probably use Binance, right? Or Coinbase. You probably use one of those centralized exchanges. So when you trade, when you exchange tokens, you submit your transaction and no one sees it. Coinbase or Binance, they don't show your information to other people. That's why you actually get a pretty good exchange rate on Coinbase or Binance. Now, if you use Uniswap, then when you submit, then there are these bad people that front run your transaction, exploit it. And the way it gets manifested is that you get a worse exchange rate. That's why, in particular, the volume on centralized exchanges is way higher. You have Uniswap, but actually the volume is way higher on, for instance, Binance or Coinbase. And with this new technology, the BITE technology that we are introducing, you'll be able to trade on decentralized exchanges as secure as you do the centralized exchanges. So decentralized will become much better, and hopefully you'll actually get way higher volume and way higher use for these decentralized applications.
Right. Yeah, that sounds very interesting. You call yourself, Scale calls itself basically a gas-free elastic blockchain network. Can you tell me a little about that? And then I would love to understand about the kind of technical challenges perhaps that have come in your journey so far, and how did your team overcome them? But first, let's talk a little about the gas-free elastic blockchain network aspect of it.
Yeah.
And if you could shed some light on that.
Totally. So let's just take a look at centralized systems, right? Let's say you want to run a website, or you want to run a web store, or you want to run a blog or social network, right? The way people typically do it, they use a cloud, something which is called cloud. And the cloud is where you are able to buy computational resources, actually unlimited, in an unlimited elastic way. In a sense that if I want to run a social network, I will probably go and procure computational resources from AWS, from Amazon, or from Microsoft, or from Google. And initially, my social network may be simple and may not have so many transactions. But as the network grows, I'll be able to buy more and more computational power from Amazon, or from Google, or from Microsoft. And that's why it's elastic. It means that when you grow, you're able to add computational power. Now, with Scale, it's pretty much the same. Let's say you run a game on Scale, and what you do, you actually buy or rent a blockchain from Scale. And let's say initially your decentralized application doesn't have so many transactions, so you just need a single chain. But then let's presume that you're super successful, right? And then you have more and more and more users. And at some point, a single blockchain is not going to be enough. So what you can do with Scale, you can go and buy another blockchain and another blockchain, and theoretically unlimited number. You pay Scale Network grows, and you are totally elastic in the sense that you don't have to worry about computational resources. So that's number one. Right. And number two is that on this blockchain, the transactions are totally free for your users. You essentially have gas. You probably know that Ethereum has gas, and you pay in transactions for gas. But in Scale, the gas is actually free. So as a dApp, as a decentralized application, you have a limited amount of gas on your blockchain, and you just give it to users for free. It's definitely not free for you, right? Very much like, for instance, if you use Facebook as a user, it's free, but Facebook actually pays AWS for the computational resources. Very much the same model we have here, where we actually shift the burden from users to the people that run decentralized applications. They pay Scale Network, but the users are actually, for the users, it's actually totally free. So when we say it's zero fee and zero gas network, yes, it's zero fee and zero gas, but for the users, for applications, it's not free. But for users, it's super great because, as you imagine, because it's free for you as a user, you don't have to have any tokens. You can pretty much just join and play the game, or you can join and use the social network, or you can join and you can use this decentralized application. Everything is free for you, which for users, it's super convenient because it's also the UI, right? If you don't have to use tokens all the time, the UI may be way simpler and actually way similar to centralized applications, such as, we're used to use all of these things like Facebook and Amazon and Google and you name it.
Which is very, very interesting. I think that, for users, it becomes a more seamless experience, right? I think we keep talking about how we want to make it easy for the users. We don't want the users to grapple with the complexities of the Web3 technology, but be able to experience Web3. And Scale is providing exactly that, right? There is no gas fee, and they are used to a Web2 experience, which perhaps they would get if, the application that they're using is on Scale.
Absolutely. And you totally got the idea. And it's actually ultimately about the user experience, because what you want to get sleek UI, right? You want the users not to worry about things. And basically then the perfect future is that the blockchain kind of dissolves. It becomes hidden. So you just use the application. It looks to you just as a regular centralized application, but behind the scenes, you actually have this blockchain which makes things decentralized and nice.
Right. Wonderful. So I'm sure that there were many challenges that you guys must have faced while building a layer 2 solution like Scale. How did you overcome them? What were these challenges? Can you talk a little about that? I'm sure that fellow builders would find a great deal of inspiration by all.
Yeah, totally. It's a great question. So when we started, we basically we took a scientific approach. So when we started, there were so many blockchains, but then you would kind of try to read the white paper of a particular blockchain, and like you couldn't understand it. And so we kind of struggled initially. And you were reading like white papers from different blockchains. They were all different. And we were trying to understand the mathematics, and it wasn't so easy. So we kind of decided to start from the scratch and understand the mathematics first, understand the computer science, and make it simpler. So what we did, basically, we took academia. We started reading research papers from academia. What we realized is that you actually use proper mathematics, things actually become way simpler. So then we said, okay, what we're going to do, instead of inventing our own thing, we're going to read all of these papers from scientists and try to compile something meaningful. First, it has to be meaningful. It has to be something also fast, but it's also provable, right? Like if you have mathematics or you have computer science, a great thing is actually to have something provable, so you can show that the thing works. And if it's mathematical, then you don't have to care so much about bugs or crashes, because mathematics actually protects you against all of those things. So we started looking into computer scientists, and we realized that we can actually create a protocol, SKALE protocol, which is pluggable, and it looks like a Lego, like a game where you have different pieces, you can combine the pieces, and then you have a working blockchain. But as you combine the pieces, you can have different algorithms from research, and when you use a different algorithm, you get a different property. So you can get things faster, you can get them more secure, more stable, depending on what computer science algorithms you use. But whatever you do in this case, it actually remains provable because you only use kind of the clean things, or only things which were proven by mathematicians and computer scientists. So we actually compiled this thing and build it. And because it's all based on research and academia, we are able to use way smaller team and actually have way more bugs or crashes because it's all based on mathematics. So our network has been running now for about like 4 years. We never had any crash or any stall or like anything getting stuck because it's all mathematical and provable. We are probably secure under the assumption of 2/3 of our validator nodes running well. And so basically the only thing we actually have to get is we have to make sure that the validators, the 2/3 of them are doing well. And then if the network actually can run. And if in the worst case, let there is something really bad happening, like a crash, for instance, on AWS or on some other cloud provider, if there's a huge crash, what's going to happen, we're going to actually pause until the crash completes, and mathematics actually helps us to recover. So there's a recovery mechanism, which is also probably secure, where if it crashed, the network crashed, and it runs again, the blockchain will actually magically resurrect itself, so to speak, and actually again run. So the entire thing is then, because of all of these things, we can sleep well, we don't crash, we can develop slower, we can improve things. And at the moment, because of all of these things, we have really great performance. We are probably the most performant blockchain algorithm now running. We run on very low power machines in the cloud, so our validators don't have to pay a lot. You can run SKALE on a $200 per month machine, and it's all because of mathematics and computer science.
This is wonderful that you kind of went back and you perused academic case studies, and you basically derived your problem from there, and you went from there. I think that is a good way to build something that actually the users will end up using. So now, when you're talking about users, can you tell us a little about the traction that you've seen so far and the kind of apps that are being built on SKALE?
So we have about 2 million transactions per day currently. We have, I think, about 15 blockchains now running on SKALE, and the number is increasing. So we have over 2 million transactions per day. Partially it comes from the fact that it's free, so users can do lots of things. And so we have 2 million transactions, but these transactions are also sometimes very complex. We're running some of the most complex, probably, blockchain applications ever. As an example, we are running a network, an AI network, which is really, really cool, I think. That's one of the interesting applications of AI that really works. So the network is called XORD, and what they do, they solve a really important problem where, let's say, you have Twitter, or now X, right? And you want to analyze Twitter or X using AI. Now, Twitter or X, they won't actually allow you to download data. You try to download tweets, you download 1,000 tweets, and they block you, essentially because you are centralized. But what Xorta does, it runs these zillions, thousands and thousands of decentralized nodes, and all of them pull data from Twitter, from social networks, bit by bit, and each particular node just pulls a little, but because there are so many of them, there are thousands and thousands of nodes, they can actually analyze the entire Twitter. As we speak, they actually, in real time, are able to pull this data from Twitter, and then what they do, once they have the data, you actually be able to analyze it using AI the way you want. But the particular thing they do things like social sentiment. For instance, you have a particular cryptography, crypto token, or you just have a regular stock like Microsoft or Google, and you want to analyze sentiment. Maybe people like Tesla, or maybe people like Google, or maybe they don't like it on a particular day. So when you get the sentiment using AI, you are able to plug it into trading, and then you are able to make a decision to buy or sell a particular stock or particular crypto based on this AI thing. So I think that's one of the probably really interesting applications of AI and blockchain. People talk a lot about AI and blockchain. It's definitely interesting. But sometimes people would just use basically two words and say, okay, AI, blockchain. But then you have to find something really meaningful. It has to be some meaningful interaction. And I think what the guys at Xorta do is really meaningful. And another really great thing we have lots and lots of games. We are probably number one now in terms of games, like top games running on blockchain, exactly because of the UI. You can actually have way nicer UI in the game if you have zero fee transactions. So we have lots of games. We have lots of new games coming. We have a partnership with Unity. I think we were the first project that actually had this partnership where there is a particular plugin to Unity. Unity is kind of an engine. Nowadays people don't actually build games. They use Unity. And then basically we have this Unity plugin, and then you can have all kinds of fun stuff and blockchain, crypto stuff inside of the game.
This is exciting. The fact that you guys are partnering with Unity is very exciting. I think because especially it is a platform that has been around for so long, and I think games really do help with any kind of a layer to show traction, to see how it kind of can scale. So this is wonderful for you guys. But now I want to play the devil's advocate a little bit. Some people at times, I have also done that argument that all rollups will eventually become Ethereum's dominant scaling solution. Do you think modular blockchains like Scale can coexist, or will one model dominate? Obviously this is a more complex way of asking, that so many L2s are getting created every other day. How do you foresee the future? Like how do you think this space will evolve, especially vis-a-vis L2s and especially vis-a-vis modular blocks?
That's a great question. I think I'm going to answer come a little bit from the history point. So first, let's take a look at blockchain, right? So initially there was Bitcoin, and it was kind of a really fun time because everyone loved blockchain, everyone loved Bitcoin. Then there was Ethereum, but then there was crypto winter. And during crypto winter, the growth of blockchain was a little bit not so great, right? I think one of the reasons was the governments, in particular the US government, was actually, they were putting lots of restrictions on blockchain. And, it was hard to start a game. It was hard to start a DeFi application. Now things changed. Now you have a new administration in the US, and, whether you voted for Trump or not, or you like Trump or not, I think it's definitely true that for crypto in particular, it's going to be good because the US government actually removed lots of restrictions. And because the US matters a lot in this world financially, when the US removes restrictions from all other countries are probably going to follow. So my prediction is for the next 4 years, what you're going to have lots and lots of growth. And also you're going to have lots of new people coming to blockchain, because during the crypto winter, especially in the US, there were engineers that were literally scared to do blockchain, and people were actually trying to leave and do something else. Now it's totally different. So crypto winter, during the crypto winter, you had lots of experimental things, but they did not not grow so much, right? You don't really see people now, like in a subway, or if you're on a bus, you don't actually have people playing so much of blockchain games, for instance, right? So it's still experimental. The entire field of blockchain, many things are still experimental from the point of view of users. Yeah, you don't have so many users, but I hope during the next 4 years, because restrictions have been removed, we're going to have lots and lots of users. And it means that lots and lots means actually, you'll actually be in a subway or in a bus, and people around you will play blockchain games. Now, if you want many people to use blockchain, let's say you want 1 billion people to use blockchain, right? You need billions of transactions per day. And then if you look into AI, if you look into some meaningful things, for instance, AI to AI payments, right? Like if one AI agent pays to another AI agent, it could be trillions of transactions per day. It could be things like micropayments, where one AI agent is using the computational power or the API of another AI agent, and maybe pays, like 1 US cent, or maybe pays 100 of US cents. So that's kind of the perfect future where people actually start using blockchain and actually moves from being experimental to being a real thing. Now, if this kind of perfect future actually works, then if you want to have billions and trillions of transactions per day, you want to have a network like Scale because of the elasticity. We actually can have millions of blockchains if people need it. With rollups, because rollups post on Ethereum mainnet, the bandwidth will still be limited. Like if you look at rollups, you have basically Base from Coinbase. I think they have like 10 million transactions per day now. And these 10 million transactions, they actually take half of Ethereum network because of the bandwidth. So with all of the rollups, currently you can only run 20 million a day. 20 million is not 1 billion and is not 1 trillion. So our hope is that with Scale, you can scale way higher. And I think definitely AI to AI payments are going to be huge. Also games, with any technology, the first thing happens is games, because gamers are pretty adaptive of new technologies. So games, AI to AI payments, things like Exogder that they mentioned, like analyzing things using AI. I think if we're going to have this billions and trillions of transactions per day, then Scale is going to actually grow really fast. And what we see actually with all of these new things, all of the new excitement, we see lots of projects actually coming to Scale. So not only we have this 2 million transactions per day, but the great thing that we are starting to see in this year, in 2025, there are many people coming back to blockchain and starting new projects. So we actually have lots and lots of cool games, for instance, which are just being built, or venture capitalists are actually now starting to invest in early stage startups that are building this new AI to applications, for instance, for AI to AI payments. So in general, I'm actually very optimistic. I think that, one thing which is kind of interesting about blockchain, usually new technologies actually grow really fast. But with blockchain, there was this period, as I mentioned, the crypto winter, which was kind of a staggered growth, and people kind of got back a little bit to being experimental again. But I'm actually really optimistic about the future, because the governments, I think they won't be able to go back. In a sense, they opened these floodgates, and I'm actually really hopeful.
I think the way you've kind of put it is one of the better ways that I have heard this particular question being defended. I think, like you mentioned, that there was a bit of a crypto winter, and now there are more kind of solutions bringing up. You've highlighted a few very good points that gaming is one of the easier, I think, fruits that can be on the path to scale for into solutions. So those are all very, very valid points. You did mention that you guys are there are more AI applications, and I think my research tells me that you also have announced an AI inference on chain. So can you tell me a little about that? How does that work? Why is it a big deal for blockchain adoption in general? I mean, I can understand it, but perhaps in simpler words, it'll be good for our listeners to get how you are really working on the crux of AI as well as Web3.
Yeah, that's a fantastic point. And AI inference, I think, is going to be one of the driving engines. I'm just going to tell you a little bit how it happens with Xorda, because it actually runs. You can actually use Xorda today to get all of the sentiment, and they have a pretty nice website. Actually, we can actually try this AI on blockchain. So basically, the question is, why do you want to actually have inference on blockchain? The reason is that if you run AI in a centralized matter, it's also always tuned, so to speak, in some way. You have ChatGPT, and you ask some question, it doesn't answer the question, or if it answers the question, it answers it in a particular way. You have a competing thing like Grok from Twitter, from Elon Musk, right? You ask the same question from Grok, and the answer sometimes will be different. If it's a question about mathematics, the answer is going to probably be the same. But if it's a kind of a hot political question, or if it's a question where there are several opinions, ChatGPT will give you one answer, and Grok will give you another one. But the point is that you don't know how it has been tuned. So it's actually better for you to have diversity. It's actually better for you to have open source AI, where you go to a particular, AI chat and you get a particular answer, but at least For instance, maybe you're politically left, you like left questions, and you go to a left bot or right, or maybe on a particular subject. Maybe you're more like a scientist and you want a question about vaccines and you like vaccines. Maybe you don't like vaccines. But in general, I think people have different opinions. So there's a question about how you resolve different opinions for AI. And probably the best way is just to have many diversity. At least when you go to an open source agent, you know how the agent has been trained and what's kind of the bias of the agent. So that's why I think on blockchain, what you can do, you can actually have many different things and having different opinions, but you know how a particular thing works. So AI for blockchain, actually, in some way, it means open source, and it also means diversity. There are different things, different opinions. At least you'll know how it's going to answer. So the way AI inference is going to work on blockchain, it actually works now on the Xorda. The data goes to blockchain. With Scale, and that's a really big point, you have to be able to store lots and lots of data on blockchain. Because with Scale, we have this elastic network. We're able to store literally terabytes of data on blockchain. And then the data is going to be on blockchain. The actual network, the neural network, is also going to be on blockchain, and it's going to be many, many different networks, open source networks. You'll be able to deploy your own network if you like a particular way to answer a thing, right? So you'll be able to deploy it on blockchain. And then AI agents need lots of computational power. So for inference, you need lots of hardware. So the agents are off the chain. So with Xorda, what they do on our chain is that basically the agents pull data from the blockchain. They do the inference, and then they push the result back to the blockchain. Now, there's one particular technical question. What happens if an agent becomes malicious and answers in the wrong way? Well, this is actually easily solvable. You can have like 5 agents answering the same question. So if one of them become malicious and doesn't use the right network, then the 4 of them will do the good thing, and the bad guy is going to be punished. So there are ways actually to protect against malicious agents. But the future, I think, is going to be diversity of opinions, open source, and blockchain. And people are actually, I think they're coming to this because people are like asking ChatGPT questions, and they're like, why isn't ChatGPT answering this particular question? Or sometimes they don't like the answer, right? These two things are going to be actually solved with blockchain.
Interesting. So so you've kind of explained to me how AI inference kind of on chain works, but do you think that this is something that you've announced it recently, right? So how soon can a user or a developer use this?
So with Xorda, you can actually use it today. You can actually go to the website Xorda. So this is one of the examples, and you can actually use this thing. I believe there are actually, we have lots of our pipeline. We have lots of early stage AI startups. So I believe that you probably by the end of 2025, you will be able to use lots and lots of these things. Definitely, they have lots of development. The good thing about AI and blockchain, there is lots of venture capitalists actually like basically doing this thing. So there are lots of money now flowing into this particular subject. People are actually working around the clock, I think, on all of the things. There will definitely be some kind of like a market like Darwinian extinction. There are a little bit too many projects, but I think overall the next year, 2025, is going to be huge for all of those things. You actually have lots of things which I actually don't like so much. You have things like AI agents, like, having some crypto tokens and trading.
Yeah.
Actually, it's a little bit of a hype application. I believe when you have some new technology, that you have always this kind of a bit of a hype thing, but they will probably subside, So the real use is, as I mentioned, in diversity, in computer science, and being able to actually run multiple neural networks. Because with ChatGPT, it's just a single network. With Grok, is a single network. But with blockchain, it's going to be thousands, maybe millions of different networks or neural networks.
Right. Okay. This is very interesting. Actually, you kind of touched a little upon my next question that I was about to ask you, but I'll ask you nevertheless. And there's basically, like you mentioned, there's a lot of talk about AI-generated smart contracts, AI agents dealing with crypto. What is your take on it? How do you think this can scale? There is also, certain specific group of people who seem to think that AI will replace developers in the blockchain space in terms of coding. I don't believe that. I think, your like you mentioned, any network is just as good as the data it is being fed. So I don't think that the human element can ever go away entirely. I might be, I might be being very optimistic about this, but I would love to get your take. What do you think about AI-generated smart contracts, developers, AI, and in general, AI agents dealing with crypto?
Absolutely. And actually, it's a fun question. I mentioned when I started that I was actually a researcher in physics. So I'm kind of a weird guy because I'm not a computer scientist, a physicist, and I have different opinions on things. So my boss at Stanford, he got a Nobel Prize in physics, and he had lots of opinions about computers, about AI, about quantum computers. Basically, if you ask physicists, not computer scientists, if you look at human brain, there is this neural network, which is kind of similar to ChatGPT, it analyzes, for instance, language. But now we're talking, I understand you, you understand me. It's all this like really fast neural network. But in addition to that, probably inside of the neurons, there are these quantum computers, which are really, really tiny. And at the moment, we don't know so many things about quantum computers. The only thing that we know about them is they can potentially run way faster, dramatically. They have dramatically higher computational capacity. So physicists, not computer scientists, physicists think that human brain has a quantum computer inside, in addition just to regular neural network. So this quantum computer is able to do things like imagination or creativity. So with ChatGPT, it can only answer questions that have been already answered. ChatGPT is basically a machine learning thing where there's lots of data, and when you ask a question, it just answers based on this data. It does not have self-awareness. It does not think, and it is not creative. One way to understand it is that, actually asking a question is a harder thing than answering a question. So ChatGPT is able to answer a question if you ask a question, but it does not able to generate its own creative questions, and it's not able to create new things. So I think the reality is that, there's a little bit of a hype about AI. AI or machine learning, actually machine learning is a way better thing because AI would probably mean actually doing a quantum computer. So what we have now is not actually AI. We have machine learning, we have lots of data. Based on this data, it actually answers questions. But this is actually very useful. So my prediction is we'll never, until we actually construct a quantum computer, we'll not be able to have AI in terms of self-awareness and creativity. And this thing, physics is not a very highly funded science at the moment. So quantum computers, when they design them, I don't know, maybe 10 years from now, 20 years from now. But in the meantime, what they call AI now, the machine learning actually, is going to be incredibly useful. So AI agents will be things to replace mundane things. For instance, when you answer emails, there are some mundane emails you answer. You pay, I pay for my cell phone, I pay for my apartment, for my utility. It's very painful. AI agents will be able to have your money and do things like really mundane, boring. But whatever boring in life is going to be replaced. So you're going to be running an AI agent on your computer. It will pay for your mobile network. It will pay for your, utilities, for your water, for your heating, whatever. And this is also going to be great. You're also going to be having robots that will also be doing mundane things. They will make coffee for you. They'll probably be able to do dishwashing or do prepare food. So all of the mundane things in the world are going to be replaced, and it's going to be happening really fast. The impact of agents on the industry is going to be great. I think AI hype coins, this is just like a really fast element. They'll subside. There's really no point in having them long term. But AI agent, like doing like mundane things, are going to be super. And also I mentioned these agents will be able to pay other agents. So you'll be able to have micropayments. As an example, if you read like a New York Times, you will be able to pay 1 cent per article. And it's not like you will be paying, your AI agent will be paying 1 cent. So AI agent, if you give a little bit of money to AI agent, let's say you have give your AI agent $20 per month, it will be able to do really, really small things that will make your life way better. And then as they improve, you'll be able to give them $100 per month. And basically they will remove all of this boring stuff, like painful stuff we have in our lives. And blockchain is great because if you're talking about micropayments, there is no way to do micropayments on centralized networks like Visa. So with blockchain, you'll be able to really, really pay for small things and AI agents. That's why I actually, as I started, we're really hopeful at scale that if these real things take off, then we're going to be doing really well with AI. So AI is actually pretty useful, although I totally agree with some people that say there's a little bit of a hype, but there's always hype, right? Like any new technology, you have lots of hype things initially.
That is bound to happen. I think with any new tech, as you said, there's going to be a lot of hype. And I completely agree with you. I think AI will help us, get rid of the mundane, and that will leave us with a lot more time to actually pay attention to what an individual really wants, and they can decide how they want to spend their time. But in terms of I still feel a little curious, and I think this is more of a philosophical question than anything else. Because we always when a technology is growing and when it is scaling, at times there are folks who perhaps don't see their potential and they don't see how it can perhaps change the way the existing status quo. So do you think that you and I might be on that side where we are not realizing the kind of potential these AI agents and the kind of power they might eventually exert in terms of tokens or micropayments or just generating smart contracts? Do you feel that is going to happen and it's a possibility?
I think it's definitely going to happen. One thing which one has to be careful about is that we actually are looking into the future where lots of things are going to be replaced by AI, and the question becomes what happens to people, right? It's a big societal question. So if everything is going to be replaced by AI, all of the mundane things, but the problem is that many people in the world, when they get paid for work, they do mundane things. So we need to start thinking about the society. What will people do, right? We don't want to have people which are going to be very lazy and basically not developing their brain and relying on just all of these AI things. So we need to build a model of the society where, yes, all of the mundane tasks are going to be totally replaced. There's no way to this. We're going to avoid this probably like 1, 2, 3 years from now. But what people are going to do is a big question. And I think that's the other side of blockchain versus AI, because blockchain can help people to and there are things like decentralized science where you pay people tokens if they do science. Science funding around the world is totally bad. People don't really invest in science. There's really important questions like cancer, for instance, biology, right? That unfortunately the society does not really solve these problems. With cancer, for instance, for the last 20 years, how much progress we had? Not so much. So a perfect society would be if we somehow using blockchain, we are able to, maybe using tokens, whatever, crypto, AI agents, we're able to pay people to do science and to solve problems that are really fundamental and really hard. So that would be a perfect society. And we actually see some of the things, like pay-per-play games where people just get paid to play games, or there are people that get paid to do fitness, to run. I think it's a good start. What we want to have, the perfect world would be where you are living in this new shiny world and you get paid every time you improve yourself. Maybe you do fitness, maybe you learn new things. Maybe you get a new degree, a university degree, right? Then you get paid. Maybe do you participate in the research? But it's a huge societal question. And it is every new technology, there will be a period of turbulence in the societies. And I think the governments and democracies, they will have to make this solution, because the kind of the dark future, we don't want the dark future. It would be that everything is done by AI, people become very lazy. But another really bad thing which can happen is the aggression, right? We see things around the world where people get paid, but then they go and get the war with other people, right? And the really bad thing would be that people that have lots of time would be engaging in wars. We don't want to have it. We want them to develop themselves. We want to become more intellectual. And I think so. So the blockchain, I think, needs to mature. The problem is that also was that during crypto winter, it was kind of a negative selection, in a sense that people that cared a lot, they were not they were actually leaving the space, while lots of hype and speculative things were happening. Hopefully, it's going to change. Hopefully, we are going to actually having these new technologies where these new tokens improve the society. And the question is very important. We cannot avoid the question, because it's incredibly turbulent time for the humankind, right? And so we need to make sure that the future is good.
Right. I think this is a very interesting take, and I think it gives me, and I'm sure it'll give our listeners, a lot to think about as well. So thank you for sharing that particular perspective.
Okay. Uh-huh.
And now I would like to ask you about the security and decentralization of Scale, because of the way it is kind of structured. What are you doing to ensure the long-term security and decentralization as the domain ethos for this particular blockchain network?
Oh, totally. It's a great question. And actually, if you compare us against rollups, we are blockchain, so we have independent validators. We don't actually control our blockchain in any way. One thing is that, sometimes people don't do open source. So you have a blockchain, and then you're asking a question, how a particular thing works, or how a bridge works, or how a transaction works. And some of the people that don't really do the open source, so you don't know. A great thing about Scale is that everything we do is open source. All of our code is on GitHub. You can actually check every single thing, how Scale works. And then we are trying to make things secure. So one thing which is actually very different with Scale is that we have hardware security. Intel processor has this hardware security protections called SGX. It's pretty much like a small, tiny processor inside of Intel chip, and it's super protected. So all of our crypto keys, all of our crypto operations are inside of this Intel SGX chip. And we are pretty much there are only one or two other blockchains that do this. So for instance, if you want to hack Scale, even if you hack into a Scale computer, a Scale node, you will still not be able to get the crypto key, because the crypto key is inside of this protected Intel chip, inside of this SGX environment. Because of this, one thing that was really good about Scale, we were running now for about 4 years. We have many blockchains. There was not a single accident with Scale where we got hacked. And I think we actually had some of the governments, like North Korea. I think you probably know this, that North Korean government attacks many blockchains, and they have people that are regularly trying to hack you. So we had some attempts, but they never succeeded. And I think they actually hacked lots of other projects. There were billions and billions of dollars going into them, essentially. But with Scale, really what happens, I think when they learned about SGX, essentially it becomes really hard investment for them to try actually hacking Intel SGX, because it requires lots of computer science understanding and actually knowledge. So they just tried other networks. So SGX was really an amazing thing for us in terms of hackers. We never actually had so much of hacker attacks, and never had a single successful attack. We never had even an attack where the chain will actually stop. So you probably know some of other chains have this high profile events where they crash, and then they don't work for a day, and they fix something and they start working. We never had something like this. And one of the things is open source. Actually, we actually have this bug bounty program, and some really cool people are trying to analyze our source code. And we did pay some bug bounties in the past, because it's all open source. People can analyze it, and they can submit the bug bounty submission, and then we fix this source code. So that actually was a pretty interesting thing for us. We never had to pay a huge bounty, so we never paid lots of money. But many people found some small things which we could improve in terms of security, and we actually fixed those things. So if anyone is listening to this podcast, if you guys want to earn a little bit of money, Scale source code is all on GitHub. If you are actually willing to find something in us, some small security vulnerability, you're welcome. And we always welcome all of the open source developers. So to answer your question again, I think open source is key. It's better to actually reveal your source and let people attack it. Hiding things is bad, I think. And that probably is number one for us. And number two is actually doing computer science and going deeper in terms of hardware. And in this case, in the example of Intel SJX, it was really, really helpful thing for us.
Right. So this is great. I think this will put a lot of folks' minds at ease that you are taking security and decentralization, and those two main concepts as something very interesting to your way of scaling your platform. This is a question that I have actually received from one of our team members, and they were talking a little about how your gas fees are reduced. Does this have an impact on the validator incentives and the kind of, again, the decentralization ethos that Scale withholds so dearly?
That's a great question. So in our model, it's a little bit different. So the network is actually collecting fees from dApps. So every dApp pays some amount of money per year for the chain. So let's say you rent a chain from Scale, you pay this money. So this money we're paying to validators. The validators actually getting the fees, and the fees are actually increasing. So our goal is to become self-sustainable. When the network started, pretty much every network starts with inflation. And so basically that happens because your network is empty, no one is running anything, but you still need to pay validators. So we started with inflation, but our inflation is getting reduced dramatically each year. And ultimately, there will be no inflation. So we're like Bitcoin. Our token supply is limited, and the end game is have zero inflation. So the end game is to have everything paid by dApps. It has to be a sustainable business model for us and for our network. So currently, we're kind of in the middle, I think. Many chains already paying, and actually, this year, everyone will be paying for chains. So we expect that in 2025, these payments are going to be much more important for validators than actually having inflation. And the payments are actually validators are paid per month. Now we have something which is called a decentralized quality of service protocol, which is another really cool thing. Basically, the validators are constantly getting analyzed by decentralized network, by decentralized agents, where every second, every minute, if a validator is not doing well, for instance, the validator is slow, the validator is not able to produce blocks, anything bad can happen to the validator. There's a reduction in the fees. So the fees actually depend on the quality of the node that the validator is running. And as I mentioned, we are pushing really hard to become self-sustainable in terms of the fees. What we want to have people pay, dApps pay, and validators getting this money. And the huge push for us is 2025 is to increase the number of chains, because we believe that in this new environment, we're going to get way higher growth, in particular applications having more users. And then as they have more users, they'll be able to run more chains and actually pay for the existing chains they have.
Wonderful. This is excellent, I think. And this is a good explanation. I think this answers the question very well. And Stan, I've just seen the time. We've completely run out of time, and I completely got lost listening because, this has been such a wonderful conversation. But before we wrap this up, I'll ask you two more questions. And the penultimate question is basically, what are the kind of common mistakes you see Web3 founders making while building any decentralized application? And I'm asking this one macro question because we've talked a lot about Scale, but with your extensive experience, I'm sure that you have some good advice for Web3 builders as well.
Yeah, that's a fantastic question. So I think the mistake that we made was because we come from scientific background, we wanted to make everything perfect. So it took us a long time to build the blockchain. We had to read all of the papers, we had to build a mathematically clean protocol. So, and probably it will be better for us to release fast and that kind of iterate. So So that was the biggest mistake. I think it's better to actually release something imperfect and then have crashes and maybe even some people complaining. So we actually took a different approach. Now, actually, it's good for us because the network is running. We're actually making incremental changes, making way higher performance. But my advice for everyone would be to actually release faster. Now, to answer your second question, I think, as I mentioned, there's a new environment and there are more people coming, entrepreneurs coming to blockchain with tiny startups. I think I would actually recommend, if you have a tiny startup, I would recommend not to go to VCs, to venture capitalists, because it's usually pretty hard to get money from venture capitalists, especially if you're not from the US or you're somewhere in the world where it's actually harder to get access to them. So my advice would be that if you have a tiny startup, first of all, just build it yourself, right? Especially with AI now, you don't have so much money. Just build it yourself, run it yourself. But another thing which is good about crypto is that you have alternative sources of investment. So basically, if you have a perfect early stage startup, it actually saves money. It doesn't really need much money. But the second thing is that you can go to different projects. There are foundations that actually are able to invest or provide grants. And people have been using this. But the funny thing what I've been seeing is that you have people that building really important startups early stage, and they don't apply for grants. But you also have grant seekers, which kind of jump from one network to another and just build, I think, meaningless things just to get money, this grant money from the foundations, and they don't up actually building anything. So what I have been pushing with SKALE, when we do grants to people, we're trying to actually filter out the spam and the hype, and actually try to understand really important things that actually are going to improve the world or actually have lots of users. So my advice would be to come up with something that actually can have lots of users, build things without actually getting any investors. And then you can probably get a little bit of money from different networks, from different foundations, from different blockchains, but use this money to actually build a meaningful thing, not just build a thing which is it's going to die next day. So that's actually a pretty good environment. The great thing about blockchain is a great investment environment. You do computer science. I would actually encourage computer scientists, people that are deep in technology, to actually go and do startups on blockchain. And actually, I think it's pretty good. I think there's a pretty good chance of success.
I think that's wonderful advice of build reshape faster and build something that is actually creating value for the end user. So Stan, this has been such a wonderful conversation.
Same.
And you kind of answered so many questions about SKALE, about just advice for entrepreneurs. There's this one question that I ask everybody who comes on the show, and I think I'd be remiss if I did not ask you the same question. You're a man of science. You made a leap from, you were doing CS, and then, you studied physics, and then, you worked in AI, and you moved to Web3. What would you say to the skeptics, or what would be your one line, perhaps suggestion for the skeptics and people who are still very skeptical about this industry, so that they can truly start living?
There's I think in Facebook they had this this thing on the wall, that you have to build things and break things. So essentially, all things in the world are experimental. It's actually totally okay to fail. And in the society, in the new society that we have, there will be a new generation. This new generation will use computers in a way we don't even imagine how they will use them. And blockchain will be definitely native to them. So the reason why blockchain will ultimately get successful is because of people that are now teenagers. For them, it is going to be the technology they will use every second, So we are building something for the children, essentially. They will use it. And no matter what happens in the meantime, there may be some crypto winters, crypto summers. I think the result will be fantastic. And I also would like to thank you so much for inviting me to this podcast. I think it was a very meaningful conversation. I also think we need to have slower conversations, deeper. And anytime I'll be happy to get back to this podcast. podcast. Also, our listeners, please, if you have any additional questions, tweet these questions to me. I really love when people ask interesting questions on Twitter. So please, let's continue this conversation, and I'll be always happy to come back to this podcast.
Thank you so much, Stan. This has been a really insightful conversation. And let me just stop the recording once, and then, we can talk about how soon you can perhaps come back, because I would love to have a deeper conversation as well. I feel like I have so many more questions to ask you. So thank you once again.
Thank you so much.
Great. Thank you so much.
Fantastic.